Okay, so a systems of linear equations is when you're given two equations and you must find the solution for both equations, so that x and y satisfy for both equations. You can get word problems like this one. This one actually may seem pretty familiar to you if you've ever invested or done anything with the banks. It says a total of $12,000 is invested in two funds, paying 9% and 11% simple interest. $1,180 is the yearly interest. How much is invested into each account? The two ways that we can solve these, there's a couple other ways, but these are the two most simple and personally my favorite. Substitution, which substitution is isolate one variable in one of the equations, substitute that variable in for the other equation, and then solve for that variable. So the way we would set that up for this one is first we get our two equations, which is going to be x plus y equals 12,000, and then it's going to be 0.09 because that is the 9% interest. 0.09 times x plus 0.11 times y equals $1,180. So for substitution, like we said, we need to isolate one of the variables. So this one, we could really do any of them. We're just going to isolate the y for now. So it's going to be y, or x plus y equals 12,000. And we want to isolate the y, so we subtract an x from both sides. We get rid of this one, and it becomes y equals 12,000 minus x. I don't know if my camera's straight off there for a little bit, but so yeah, basically what we did, we crossed that out. That's our x's, this is our y, equals 12,000. We cancel out the x's, and this is what we're left with. So we go back to our original equation, 0.09x plus 0.11y equals 1,180. And we now have a value for y. We now have y equals 12,000 x. So we go to this y, and we see, 0.90x plus 0.11y, and we establish that our y equals 12,000 minus x equals 1,180. So now we're left with only our last equation only has one variable. So for this one we would just distribute this. I hope you remember distribution. 0.11 times 12,000 minus 0.11x equals 1,180. And we also have 0.09x plus. Alright, so this is a lot of math, and I don't really want to do that right now because I don't have my calculator, and I'm already running at 3 minutes on this video. So that's basically how you do it. I'll go through an easier one in a minute. But that's substitution for you. You basically, now for this last one, we would just solve that for x, and once we got the x value, we would just plug it back in for our x plus y equals 12,000, and we would be able to figure out y pretty easy from there. So now we're going to go to the next, which is elimination. Elimination, you add the two equations together so that one variable is completely eliminated. You may need to manipulate one of the equations. For pretty much all of them, you'll have to manipulate it. But here we have just a simple equation. It's 3x plus 2y equals 17, and 2x minus y equals 2. So for this one, you would look at it and you'd say, how can I eliminate one of those things? Right here, I see that we have a positive 2y, and right here I see that we have a negative 2y. So or a negative y. Now I want to get this to equal negative 2y, so that when I add these two equations together, these y's will cancel out. So what I'm going to do is I'm going to take this, and since I need that negative y to equal negative 2y, I'm just going to multiply this entire equation by 2. So we distribute it out, so it'd be 4x minus 2y equals 4. Since we're multiplying the whole equation, we can do this. And now I'll write my other equation right here, 3x plus 2y equals 17. Okay, so I have 3x plus 2y equals 17, and I can actually add this equation all the way down. So I have 7x, and the beauty of this is these two cancel out because the negative 2y plus the positive 2y is 0. So that is plus 0 equals 21. So now I am left with 7x equals 21. And now I can just divide by 7, and I get x equals 3. Now I could go back to one of these equations, any of these really, up top, and I'll just choose this one real fast. 3x plus 2y equals 17. I now know that x equals 3, so I can 3 times 3, because that's the value of x, equals 9. 9 plus 2y equals 17. Subtract the 9 from both sides. You get 8. 2y equals 8. Y equals 4. So now the solution for this system of equations is x equals 3, y equals 4. Now if you're writing this in on a point, it would be 3, 4, like that. Now I'm going to get another sheet of paper if I can find one. Just going to be back around quick. Okay, so now I'm going to solve this same equation. The same system of equations, except for I'm going to use substitution this time. So I have the same exact one, right there, and right there. And now I'm going to solve it using the substitution. So now, if I'm looking at this, I don't want to substitute. I don't want to isolate one of the variables for this one because it would involve a lot of tricky or just messy division, and you'd have a lot of fractions everywhere. But for this one, I notice that I have a lone y. It has nothing else is on it. It's just y by itself, a negative y. So for this one, I'm going to isolate that variable right there. So I have 2x, and I'm going to add y to both sides. So this y cancels out, and this will then become equals, oh, I messed up. No, I did it right. 2 plus y. And now since I have y on this side now, I need to subtract that 2. So I'm subtract 2 from both sides, and I have 2x minus 2 equals y. Now I have y by itself. So I can go back to this first equation right here, and I can substitute y for that. So since my y equals 2x minus 2, I have 3x minus or plus 2 times 2x minus 2 equals 17. Using distribution, I have 4x minus 4. I forgot my 3x right there. 3x plus 4x minus 4 equals 17. Now, this should be pretty clear.